Last one, as well as this one, it did ask me to verify this on a calculator. Please remind me to show you how to use your calculator in class. Again, there's so many different calculators that you guys are using, so it'll be much easier for me to talk about those during class. What we're going to have now is another definite integral. We're going to go ahead and solve for this one. I actually had two problems and I realized that just now, so apologize for that. So u equals 2x minus 1. This one again is not as easy just because I don't get what I need. I need an x dx, not a 2 dx. So I'm going to have to take this off to the side and say, well, u plus 1 equals 2x. So x is equal to u plus 1 all over 2. So now I'm going to go ahead and start to rewrite this. So I would have the x part up top as being u plus 1 over 2 all over the square root of u. I only want a dx, so I'm going to have to move my 1/2 to the other side. So I have 1/2 du. This is an absolute mess right now, so we're definitely going to be needing to do some simplifying. So as I look at this, I am going to first rewrite this as 1/2 u plus 1/2 all over u to the 1/2 du. Let's see what this allows me to do. Well, I could actually pull out my 1/2 because there's a 1/2 on each one of these. So I have 1/2, and I'm going to go ahead and rewrite this. 1/2 u plus 1 all over u to the 1/2, just in case you don't see what I'm doing. Now I can pull out my 1/2, which gives me 1/4, and then I can divide each of these off. So I get u to the 1/2 plus u to the negative 1/2. Now I need to also figure out my new bounds. I've left those off. So I'm going to come back up here, plug in my 1. So I have 2 minus 1, which is 1, and then plug in my 5, which will give me 5 times 2 is 9, minus 1 is 8. So I have my new bounds of 1 to 8. Or I mean 1 to 9, excuse me. That should be 9 because it's 10. So now I'm ready to integrate this, which would give me u to the 3/2, and it'd be over 3/2, which would put a 2/3 out front. I'd have u to the 1/2 over 1/2, which would be 2. And I'd have I don't need plus c because I'm going to be plugging those in. So I end up getting 2/3, 9 to the 3/2 plus 2 square root of 9. Minus, so we'd have the same thing by plugging in 1. Well, that would be 1. So I just have 2/3 plus I'd have 2. And I'm multiplying by 1/4 at the end. So the square root of 9 is 3. 3 squared is 27. So I get 54 over 3 plus 6 minus, this would be 2 and 2/3, which would be 8/3. And we're multiplying by 1/4 at the end. So I end up getting the answer of 18 plus 6 minus 8/3 being multiplied by 1/4. And when you simplify all that, you end up getting 5 and 1/3. And I'm squeezing that in there. My last problem I probably will not be able to finish. I'm not going to make a whole nother video for this. This would be u to the x, or u equals x squared to make my du be 2 dx. And then I'd replace this with secant or cosecant u cotangent u. And then I'd only need a dx, so I'd solve for this, and I'd have 1/2 du equals dx. So I have 1/2 du. Well, I know this, I need to change my bounds. So my bounds would now be pi over 6, and put in pi over 4, I'd get pi over 2. And so when I integrate, I end up getting negative 1/2 cosecant u from pi over 6 to pi over 2. And I will go ahead and tell you what the final answer is because I will not be able to finish this in this video, but you should get 1/2. If you don't get 1/2, we can discuss that in class.